Hi everyone, welcome back to the channel, and today I'm here with the first lesson of our DSA lesson series. And today we're going to talk about stack deck, or the concept of implementing a deck using stacks. So if you think about a deck, a double nut queue is something like this. Okay. Okay, something like this, which has two openings, and a deck uses both of its openings to do the insertions and deletions. So you can insert elements from here and remove from here, and also you can insert elements from here and remove from here. So if you think about a stack is somewhat of something like this, where it only has one opening. So it uses the same opening to do the insertions and deletions. It's something like this actually. As you can see, it only has one opening, and it uses the same opening to do the both insertions and deletions. So today what we're going to do is that we are going to implement a deck using stacks, but the problem here is the stack only has one opening, right? But as I mentioned before, a deck has two openings. So what we are going to do is that we are going to use two stacks. So there will be two openings, and we will be able to implement a deck. So the point we have to keep in mind is that this idea is a bit conceptual. I mean, it's possible. I'm not saying it's possible. Of course, it's possible, right? But the thing is that these two stacks don't have any physical connection. All right. So the logic is the thing which binds these two stacks together and allows them to mimic the behavior of a deck. So let's see how this implementation works. Okay, let's look at the code implementation. Before creating a deck from stacks, first we have to create stacks, right? So to create stacks, here I have used stack class. I have imported the stack class, and using this stack class which I created, I will be implementing stack using stack class. And here are the methods that will be used by the stacks. The push method to insert elements into the stack, the pop method to remove elements from the stack, the peek method to see the topmost element in the stack, and isEmpty method to check if the stack is empty, the size method to check the size of the stack, and the display method to get print all the elements inside the stack. So this is the class stack using stack is the class which I will be using to create my stacks, which will be used later to implement our deck. So okay, here we will do the main implementation, which will implement a deck using stacks. So first, when we create an object using this class, which is a deck using stack deck class, it will automatically create two stacks, which is front stack and back stack, from the stack using stack class I mentioned earlier. So let's draw that. So this is our front stack, and this will be our back stack. All right. And here we have the methods that will used by this deck. So add first method, add last method, remove first method, remove last method, peek first, peek last, and isEmpty, size, and all that. So what this add first method does is that when we call the add first method, it pushes the item to the front stack. Let's draw a deck. and name the endings as front and back. Alright, so at first means adding from the front, at last means adding from the back. Remove first means removing from the front. Remove last means removing from the back. So when I call the add first function, it pushes the element to the front stack. Let's say I call the add first and gave the argument x, then it will push x to the front stack like this. Alright, so the x will get inserted from here, this side. Then the add last function, when I call the add last function, it pushes the element to the back stack, which means if I call the add last function and give the argument y, then it will push the y into the back stack. It's like this, which will like the high level view is the y will get inserted from this side, because that's the at last. Okay, then we have the function remove first. Alright, in this remove first function, if we have called the is empty first to check if both the stacks are empty. If both the stacks are empty, there are no any elements to pop, right? So we just say there is an exception. So if only the front stack is empty, let's assume that the front stack is empty. Alright, front stack is now empty. We have front stack is empty. Okay, front stack is empty and we have x and y in our back stack, just like this now, x and y here. Our front stack is empty. So what happens is that when we call the remove first, it should remove from the front, right? So it should remove from the front, which means the element that should get out is what? X should get out from this side. But how we can do that? Because x is here, usually in stacks only the top element gets popped, so y will be the one which gets popped. So that's where we use the transfer function. In this transfer function which we have created here, right, it takes two parameters, which is from which stack to which stack. So it takes the two stacks as the parameters and transfer the elements between those using a while loop, like until one stack gets empty, pop from that stack and push to the other stack. So here first y will get popped and will be pushed into here, then the x will get popped and pushed into here, right? Which is just like y will get inserted here, x will get inserted from here. Alright, then we can front stack pop, which will pop x. that's what we had to do, and now the X is getting popped, so the remove first function works fine, right? So that's the simple logic behind this, and that logic is the same thing which will be applied to the remove last and also the peak first method, peak last method, and all those methods. Here we have the isEmpty method to check if the deck is empty. First we will check both the front stack and the back stack is empty or not, then combine the results and return the output. So we have the size, which will get the front stack size and the back stack size, and add them together and return in the value. Then we have the display function, which will print out all the elements from the front stack and the back stack. So here we have the main method, and okay, so here we have created our deck using two stacks, right? Then we have called our functions that we created. So let's see how these things will work, right? Okay, deck add first 10, add first 10, FB. So these are the two stacks that will get created, and these are the two stacks which will act as our deck right here. So add first means from adding from here, so it will push 10 to the front stack, 10 to here, so 10 comes here. All right, 10 comes here. Then add last 20, which is add last 20 means back stack push 20 from here, so 20 comes here. Right, then we have add last 30, which means add last 30 to here, 20, 30. Okay, then we have deck add first item 5, add first 5, so here add 5, 5 will come here now. Okay, then deck display, so it will display all the elements from the front stack and the back stack, which will like display front stack 5, 10, back stack 20, 30. So then we have system out println front element deck peak first. Actually deck peak first, what deck peak first will do is a front stack peak. So front stack peak will give you 5, and it will give you 5. Okay, then we have what, then we have peak last. Peak last means peak first, like peak last of deck means peak first of back stack, so which gives you 30, and here also 30. Right, then we have deck remove first. Remove first means popping the element, the topmost element of the front stack. 5 gets removed. Then remove last. Remove last means popping the element of the back stack, topmost element of the back stack, which is 30, and 30 will get popped. then display. When we display this, then it will give us like front stack 10, back stack 20. Alright. So here it has asked for the deck size. So the deck size will be 1 2 elements, so deck size will be 2. So let's run this. Yeah. Here we have the first display one, front stack 10 5, back stack 20 30. The front element is 5 and the back element is 30, which is like this. Then removed elements are from the front 5 got removed, from the back 30 got removed, right? So then we print stack, it will get like 20 and 30. It's like this, 10 and 20, sorry, 10 and 20. Then size will be 2. So I think you got a clear idea about how this implementation of Deque using stacks work in Java. Okay, now we are come to the end of our lesson. In this video, I hope I gave you some insights about the stacks, Deques, and the implementation of stack Deque and how it works. So if you find this video valuable, like the video and share this to your friends, and also subscribe to the channel, and also click the notification button to be notified. Thank you.